Hello again, everyone. In this session, we're going to have another MSTE word problem, and this is our series number 34. By this time, let us try solving a difficult problem. Let us start solving now a sample problem. Our civil engineering word problem for today is actually possibly extremely difficult problem because the style is like a math Olympiad problem. Now our given problem is this. If a square plus b square is equal to 3ab, we have to determine the value of a plus b all over a minus b. Then open and close parenthesis raised to the sixth power. Let us now start solving the problem. Actually, we have three steps to do in order to solve this problem. As we can see, the question, find a plus b all over a minus b, then raised to the sixth power. We have to apply here the power of quotient. Let's separate the computation for the numerator and the denominator like this. First, we have to determine the value of a plus b raised to the sixth power and the denominator a minus b raised to the sixth power. That is why we have to do this first. For the first step of our solution process, we have to determine first the value of a plus b raised to the sixth power. The given equation in our given problem is a squared plus b squared equals 3ab. Now, using this equation, we have to strategize that the left-hand side of the equation must be in a form of a square of binomial. In order to do that, we must add 2ab on both sides of the equation, wherein originally it is a squared plus b squared equals 3ab. Again, originally, this equation now is actually originally a squared plus b squared equals 3ab. But since we have added 2ab on both sides of the original equation, this is now how it looks. If we will read it, a squared plus 2ab plus b squared equals 3ab plus 2ab. Coming up next, we have to factor the left-hand side of the equation by using the type of factoring perfect square trinomial. We need to factor a squared plus 2ab plus b squared, which will lead us to a square of binomial. Now we have a plus b raised to the second power equals 5ab, because from our preceding equation, if we're going to factor a squared plus 2ab plus b squared, that is equal to the square of binomial a plus b, while 3a plus 2ab equals 5ab. And for the next step of our solution process, we have to raise both sides of the equation to the power of 3 as exponent. And as we can see now, both sides of the equations are raised to the third power. And allow me to read it. The square of a plus b, open and close bracket, raised to the third power is equal to 5ab, open and close bracket, raised to the third power. And then afterward, what's next? We must apply then and utilize the power of power rule under the laws of positive integer exponents so that we can simplify our given equation like this. As we can see now, we have the sixth power of the binomial a plus b equals 125 a cubed b cubed, wherein the numerator of our required question was already computed. Let us now proceed to the next step. Our next step now is to evaluate the binomial a minus b raised to the sixth power so that we can calculate the denominator of our required question. Let me utilize again our given equation. Originally, a squared plus b squared equals 3ab. Again, let's strategize that the left-hand side of the equation be in a form of a square of binomial, which is actually a spatial product formula. In order to do that strategy, we must subtract 2ab on both sides of the equation. Originally, it is a squared plus b squared equals 3ab. If we're going to subtract 2ab on both sides, our equation will become a squared minus 2ab plus b squared equals 3ab minus 2ab. Then, our next step is to factor the left-hand side of the equation by using the type of factoring perfect square trinomial, which means a squared minus 2ab plus b squared can be factored as square of a minus b. But still, we have to simplify the right-hand side of the equation, 3ab minus 2ab. That is just simply equal to ab. After doing that, now our equation is like this. The square of a minus b equals ab. And then again, just like what we did previously, we need to raise both sides of the equation to the power of 3 as exponent. In doing that, our equation now is read as the square of a minus b, open and close bracket, to the third power equals ab, open and close bracket, raised to the third power. And then similarly, just like the previous what we did, we have to use the power of power rule under the laws of positive integer exponents. Finally, the value of a minus b, open and close parenthesis, raised to the sixth power, equals a cubed plus b cubed. We can then now move to the last step. Our last step now is to determine the value of a plus b all over a minus b raised to the sixth power. In order to solve the problem very easy, let's not forget this. Apply the power of quotient. After applying the power of quotient, are given a plus b over a minus b raised to the sixth power will become a plus b, open and close parenthesis, raised to the sixth power, all over a minus b, open and close parenthesis, raised to the sixth power. But we have already calculated for the value of a plus b raised to the sixth power and also the a minus b raised to the sixth power. What we must do now is the direct substitution process. The value of a plus b raised to the sixth power is 125 a cubed b cubed, while the denominator a minus b, open and close parenthesis, raised to the sixth power equals a cubed b cubed. Simplifying this expression, our final answer to our required question in the problem is our final answer to the question, the sixth power of the quotient of a plus b over a minus b equals 125. Thank you very much and God bless us all.